an OPC server. It's an OPC 2.0 DA, or Direct Access Server. It connects via Ethernet to a master CX, which proxies data back to it. What that basically means is that the OPC server doesn't go to each of your field controllers and request the data directly. Instead, it asks a controller which you've designated as the master CX to get the data for it. It's important to note that it doesn't communicate with CX controllers via serial window. Some third-party Andover OPC servers out there do it that way. Andover Controls, their OPC server, is Ethernet-based. Andover's OPC server, unfortunately, does not implement any security mechanisms. That's important to understand. Basically, what it means is that once you bring up your OPC server, any OPC client that can discover the server essentially has full access to change or read any of your field points. Because of that, it's important to learn how to lock down your OPC server and the machine that it resides on. Finally, there is no such thing as an Andover OPC client. Essentially, if you want a client, you have to do everything backwards in order to get the data into the Andover system. Of the various interfaces that the OPC specification defines for OPC servers, it can be seen that Andover's OPC server is a 2.x DA server. This is based on the fact that Andover's server does not support IOPC browse and IOPC item IO, which are required in the 3.x versions of OPC server. Let's take a look at setting up and configuring Andover's OPC server. I found that it actually runs best on a machine that's not running Andover CyberStation. With CyberStation running, I was getting some occasional ACC data services errors. The installation of the OPC server is achieved by running a standard install shield setup. It copies the files and registers the server in the registry. It's pretty straightforward, so I'm going to skip this part. Instead, let's take a look at the application itself and its configuration. The first time you run the OPC server, you need to provide some configuration information. You need to give an IP address of a primary CX controller. By primary, this means that it's the only CX controller that the Andover OPC server will communicate with. This controller acts as a gateway to all other controllers and points on your Andover network. You need to give the primary node name and the energy net ID of this same controller. LL password is a field that's not discussed much in the manual. What it is a numeric that needs to exist on that same CX controller, and the values need to be equal to each other. In this case, I have 3 in both of them. It's a sort of simple security that prevents someone else from bringing an Andover OPC server onto your network and querying and setting your points. If it doesn't match up, the OPC server is unable to communicate with the CX controller. Next, you need to specify the controller type, either Continuum or Infinity. The minimum scan period is the minimum amount of time for a group of points to be scanned. That means that even if your OPC client asks for the points every 50 milliseconds, if this is set as 5,000 milliseconds, they can't pull those points any quicker than that. Mode specifies either synchronous or asynchronous. Synchronous is going to gather the points one at a time and wait for a response from the CX. Asynchronous will make the requests many at a time, and as the results come in, it'll publish those results. You can enable write protect on your OPC server so that points cannot be written to. Unchecking it allows the OPC server to set points on your Andover network. Under status default, I have pull time threshold. This is the maximum amount of time, supplied in milliseconds, that it can take to read a group of points. If it takes longer than this, in this case 5 seconds, the OPC server will throw an exception error. Error logging allows me to log these errors. I can save this to a file by enabling it and specifying the file name. For this demonstration, I'm going to skip over controller performance tuning. It's something that's covered extensively in the Andover documentation if you need help on this subject. Now that we have the OPC server configured, let's try to connect to it. I'm going to use something called Matricon's OPC Explorer. It's an OPC client application that allows you to connect to and test OPC servers. Here I see Andover controllers.controller OPC server.1. If I click on this, I can see the supported interfaces for my server. As we mentioned before, Andover's OPC server is a DA 2.0 OPC server. It does not support HDA, which is Historical Data Access, A&E, which is alarms and event, or security. I'll go ahead and press the connect icon in order to connect to my OPC server. Now that the Matricon OPC client has connected to my Andover OPC server, I can see that the OPC server did in fact start. It shows up in the start bar. This would have happened anyway, but since I happen to be on the same machine, I'm able to see it in the start bar. Inside the OPC server, I can click on View and then choose to enable different types of messages. I'm going to enable Read and Write messages. That's going to allow them to show up in this white dialog area. If I click on Tools, I can also enable Statistics. This brings up a dialog box that allows me to see the total number of reads, the average take read time, maximum group poll time, total number of writes, how much memory it's using, and some other statistics. Back in the Matricon OPC Explorer, I can right-click on my server and add a group. I'll give the group a name. Set the update rate in milliseconds, and click OK. I now see a listing of my controllers on the network. In this case, I have a BCX controller and several CX controllers. If I expand one of the CX controllers, I can see the types of points that are available: inputs, outputs, even programs and schedules. I'm going to select an input point. Choose the available tag, which is synonymous with Andover's attributes, and add it to my group. I'll do this with several of the points. After I'm done adding the points, I can see that they are now populating in my group. I see the name of the point, or the tag name, its current value, the quality of that read, and the last timestamp from when it was read. If I switch over to my OPC server, I can see that it's now updating data, giving me the timestamp, the tag name, and the value that it is serving. Finally, you could have any client software add multiple groups to be pulled from the OPC server. I've added HVAC, lighting, and some process control and security, which might include door points. For any of these groups, the OPC client at any time can deactivate or reactivate the group. It can choose to change the polling mode from asynchronous to synchronous, perform a demand read at any time, add or remove items, or change the update rate. In this case, I'm going to change it from 5 seconds to 120 seconds, or 2 minutes. Matricon's OPC Explorer is a simple client that's primarily useful in testing of new OPC server installations. But since the concepts are really pretty much the same across the board, regardless of what client software you use, it's a pretty powerful illustration of just how easy it is to connect an OPC client to Andover's OPC server.